We know that this is m2g. So m2g equals m1g sine alpha minus f max. Notice the difference. There's a plus sign here, there's a minus sign here. This is, the object is still not moving, but if I make m2g a hair less, just a teeny little less, it will definitely start to accelerate downwards. So if I make this smaller than sign, the object will start accelerating downhill. This is condition 1, this is condition 2. If the condition is neither 1 nor 2, what do you think will happen then? It's very possible that you don't meet any one of these two conditions. What do you think will happen? Can't hear you. It won't move. A is 0. Because these both cases is going to accelerate. So in all other cases, the acceleration equals 0. And the frictional force in this case will adjust itself just the right way so that Newton's second law in the x direction will give you for the force a 0. Let us take a very simple example so that you see this at work. So we have an example here. And in my example, I have m1 equals 1 kilogram, m2 equals 2 kilograms. Can't make the numbers much simpler. I take alpha equals 30 degrees. I take a static friction coefficient, which is 0.5. And I take a kinetic friction coefficient, which is a little less, which is 0.4. The question is now, is it going accelerated uphill, or accelerated downhill, or no acceleration at all? What it comes down to is that we have to evaluate these three terms. Let's first take m2g. m2g equals 20. We'll just take for g 10, that is just easier. m1g sine alpha, the sine of alpha is a half, so that is 5. m1g sine alpha equals 5. And what is ff maximum? I have to use for my friction coefficient 0.5. I have to use for m11 here a 10 and have the cosine for 30 degrees. And what I find, you have to take my word for it, that this is about 4.33. And I want to remind you, I have used the static friction coefficient. And this is in newtons. I never put a capital N for newtons because that is very confusing with this normal force. All my units are always in SI units. So the force is always in newtons. Aha! We're well on our way. Let's first test whether condition 1 is met. Is 20 larger than 5 plus 4.33? And the answer is yes, it is. So we know that it's going to be accelerated uphill. That is non-negotiable. So now I could ask you a simple question. What is the acceleration and what is the tension in the string? And so you will think, oh well, that is within arm reach. Not quite. Because things are now going to change. If it is going to be accelerated uphill, then at least I know one thing, which I'm going to put in this drawing now. I know that this is the maximum friction possible, which now becomes mu kinetic, because it's going to move, times m1 times g times cosine alpha. So that is already one change. It is moving, for sure, it's going to be accelerated, so the frictional force is in this direction, has this value. So let's write down now Newton's second law in the x direction. So we have t in the positive direction minus m1g sine alpha minus this maximum force minus mu k m1 g cosine alpha. And that now, according to Newton's law, must be m1 times a, if a is the acceleration uphill. One equation with two unknowns. You don't know a, and you don't know t. Or do you know t? What is t? What is the tension? What is the tension when that thing is being accelerated uphill? Anyone has the courage to try? You think m2g. You couldn't be more wrong. It's now moving. It's being accelerated. That means this object is going to be accelerated down. And if this force is the same as this, it can never accelerate down. This t must get smaller. Remember, an object in an elevator being accelerated down loses weight. It's losing weight. This object must be accelerated down. We have to take that into account. So the tension, once it starts accelerating, will go down. So I have a second equation for object number 2. I call this the plus direction. So for object number 2, I have m2g minus t equals m2 times a. It is very important that you see that the tension will change. Now I have two equations with two unknowns. And now I can solve. It's very easy. You just add them. And I leave you with that. I'll just give you the results. I find that the acceleration, a, equals plus, I think 3.85. That is correct. Plus 3.85 meters per second squared. And I find that the tension equals 12.3 newtons. I want to dwell on this a little bit. I find for the acceleration a plus sign. Had I found a minus sign, I'm sure I would have made a mistake. Why is it mandatory that I find the plus sign? Absolutely mandatory. Who wants to try that one? Yeah?
Well, if you put the friction fraction into opposite acceleration, the accelerating fraction.
Yeah, you say it well. I would have said it slightly differently. We know that the acceleration is in this direction. We derive that. Therefore, the acceleration, since I call that the plus x direction, that was my plus sign, must come out plus. So if this comes out negative, you've made a mistake. I also want this number to be less than 20. If not, I've made a mistake. Why does that number have to be less than 20? Exactly. This object is going down. To put it the way we put it last time, it lost weight. It's accelerated downwards. This mtg, which is 20, better wins it from t, otherwise it would never be accelerated down. So this plus sign is a must, and this is a must. And if you find not a plus sign but a minus sign, you have to go back to your calculation because you've made a mistake. Now, we take the same situation. I leave everything unchanged, but I make the second mass, m2, I make it 0.4 kilograms. So now all the numbers remain the same that we have there, except that m2g now becomes 4. Now I'm going to test again. Is m2g, which is 4, is that larger than 5 plus the frictional force static, 4.33? The answer is no. I'm going to test for my second case. Is m2g smaller than 5 minus 4.33? The answer is no. So what do we conclude? What must be our conclusion? Condition 1 is not met. Condition 2 is not met. Conclusion is A is 0. The object will not be accelerated. And the frictional force is going to adjust along the x direction so that the acceleration indeed is 0.